So today we are going to be in 6.3. We're going to be talking about these things called logarithm, and we're going to just start off kind of with a basic understanding of logs and what they are. So you guys have seen things where I call it power form. So if I had some number and then I raised it to a power, that would equal some other number. So this would be some number to a power, and it would give me another number. So if like I did 2 to the third power, that would be 2 times 2, which is 4, times another 2, which is 8. So this is called exponential form. We've dealt with this. This is exponential form. What we're talking about today is called log form, and they're kind of, they're very related. So what happens is if I want to take something that's an exponential form and put it to log form, it would look like this. Log A would go there. C would go here. And then B would go here. So you noticed the A would go here. The B would go over here, and the C would go to here. And so like if I was changing this from exponential form to log form, this would turn into log. This would become what we call our base, which is down here, 2. The 8, which is the answer, would go here, and then equals 3. I know that's a kind of weird, but just look at and follow the. I notice I put them in certain colors so you can kind of follow along where they go, and you're going to be practicing going back and forth from exponential to log, and then also from log back to exponential. So to give you an idea for that, if I had log of, let's say, 4/16 equals 2. The way you do this is this going from log to power. This is the base, which means that's the bottom number, to the second power, which would go here, is equal to 16. So I kind of do that little circle rotation. I go, this is my base right here, to this power equals that. So that's what I always do when I change log. So log, I'm doing ones you should be familiar with. Right, so that would mean 5 to the second power equals 25. So part of your homework is just going to be going back and forth and changing log to exponential form and changing from exponential back to log. Now, if someone gave me a problem like this where it says log 5/125, and they ask me what the answer is, this is going to be the unknown, right? So that's the x. So sometimes in log form, what I can do is change it back to exponential to help me out. So I can say 5 to the some power equals 125. So what I'm looking for is how many times do I multiply 5 by itself to get to 125? And hopefully you're realizing that the answer is 3. And so sometimes you can't see it so easy. So what you do is you take 125 and you do that breakdown that we did, which is 25 times 5, 5 times 5. And you realize that 5x equals 5 to the third power. Well, if these bases are the same, that means that this exponent would have to be equal to this exponent. So x would have to equal 3. And I'm kind of writing it like that on purpose because later on we're going to use that type of understanding that if the bases are the same, then it has to be raised to the same power. So this has to be equal to this. So I'm just going to keep going through a couple different examples of things like that. So if I had log 1/4 into 16th, so log 1 base 1/4 16 equals, again, this is the x, so this would mean 1/4 to the x equals 16. Well, the only way that I can get this to be flipped up is if this exponent's going to be negative. So what I would think is, if I wanted to pull this up, I could make this 4 to the negative x, and that would equal, and if I break 16 down, that's 4 to the second power. So if I notice right here, they have the same thing. That means that negative x equals 2. Well, I don't want it to be negative x, so times by negative 1 times by negative 1, and I realize that x would have to be a negative 2. And again, we've talked about if I had 1/4 to the negative 2, this would belong to both of them, and so that would become 1 to the negative 2 over 4 to the negative 2. And anything that has a negative exponent touching to it switches location, so the 1 will come down, the 4 will go up, and that becomes 4 squared over 1 squared, which is 16 over 1. And so 4, or 1/4, to the negative 2 power does equal 16. That is correct. All right? I had log base 3, 0 equals, this is the x, so I need 3 to some power equaling 0. Well, there's no answer for this because even 3 to the 0 power equals 1. 3 to the first is 3. 3 to the negative 1 is 1/3. All it does is change that back to the bottom. So there's no answer. This is no solution. There's no way that this will ever become that. So sometimes that can happen in these examples. And then log 2 to the 8th equals x. All this would mean is this 2 to the x equals 2 to the 8th. Well, right there, you've already got the bases being the same, so you know the powers have to be the same. So that tells you that x has to equal 8. All right, so hopefully those couple examples weren't too difficult. Then we have something that is called natural log, and we also have what's called common log, and we will use these a lot more later on, but we're just kind of laying some groundwork for these. So if I have log and nothing is written next to here, meaning kind of like if I have an x and there's nothing written next to it, it's understood to be a 1. This is actually understood to be a 10. So if you see log and then 900 or something like that, or let's make it one that we can do in our heads. Where's my eraser button? There you are. If I had log 100, and they're asking what that answer is, this is understood to be a 10. It will not be written there. That's why I'm dashing it. If it's not written, it's understood to be a 10, and basically they're asking 10 to what power equals 100. Because here it is. This not written there is 10 to the x power equals 100, and so my answer would be 2. Okay, so that is called common log. Common is base 10, so if it's not written, it's understood to be a base 10. And then you also see this thing called ln. ln is really the log with what we call a natural log, with that e number that we've talked about when we did the PERT. This e right here is the same e as this. Whenever you see ln, it's really the same thing as log, but using base e. And there's a button on the calculator. You'll see a log button, and it will just say log. That is the common log, meaning it is base 10 every single time. When I have ln, it's the same thing, it's log, but its base is e. Base is e. Now, when I have log 2 into the, let's say, log base 2 and 10, I can't actually use a calculator right now. I'm going to teach you how to actually put this in the calculator, but I can't use the calculator for this because this is base 2, and the log button on the calculator is only using base 10. This will feel a little bit confusing in the beginning. Remember, it's the first time we're seeing this. It will get better as we are going to use this a lot. So please don't feel like you have to be 100%. Just kind of keep going with it. Look at how we're changing the stuff. Make sure you come and see me on the next day when I have the homework help. And I've only had like 5 to 7 people who are showing up each time. So please make sure you get to those. Then the final thing we're going to talk about is how to use this, and we're going to do this a lot more. So this is just, again, the basics. How to solve a question by using a log that is not there to help us. So the great thing is, see, this x is up in the exponent, and I got to find a way to get that down from the exponent in order so I can solve for it. So what we do is we log this side, and we log this side. And what happens is this really turns into log base 10, right? Because it's not written there. Base 10, 25 equals, and then this is log base 10, 10 to the x minus 1. And what happens is these guys cancel each other out, bringing the x minus 1 down. So I end up with log 25 equals x minus 1. So that allowed us to move this out of the exponent. And then what I want to do is get x by itself, right? So I'd add 1. And like I said, you can put this in the calculator, the log button on the calculator. So you're going to hit log, then 25, and then add 1 to it. And your answer, when you do that, you should get x equals 2.398. So make sure you can try that, practice using that in the calculator. And then finally, another one that we can do, this will be our last one we're going to do right now, is ln, which means now I'm in natural log. 2x plus 3 equals 4. And in this case, I don't have the x as the exponent, but it's right next to the ln, so I want to get rid of the ln. So what I do is I take and I raise everything to the e power, and then the ln and the e cancel out, bringing this so that there's no ln by it, and I have e to the 4th power. I can put that in my calculator, and that's going to kick out some number. Remember, you want to try to round towards the end, so you want to try to write this out as much as you can. So when you put this in your calculator, you should get something around 54.598. And then we would just solve for this x by itself. So we'd minus 3, and we'd get 2x equals 51.598, and then divide by 2, and you should get x equals something around 25.799. So that should be your answer. All right, so you're going to practice kind of using those skills for the first part. We're going to get a lot more detailed into that. Really make sure you understand how to change from exponential to log and log back to exponential. Make sure you understand that, where's it at? Make sure you understand that log by itself, over here, that log by itself is base 10, and if I have ln, that's really log e. Those two are the same thing, but we write it as ln. So just make sure you understand those things, and you should be good for this section. All right. Thanks for that homework. Make sure you practice it, and again, the next day I'll be going over it. So if you have questions, make sure to see me on the live, probably 10 and 1 again. All right. Have a great day, guys. Bye. Actually, I forgot to tell you something. Please make sure you are uploading your homework. Please try to upload in Teams first. It is easier for me to grade in Teams. So if you can try Teams, I will continue to allow you to upload in Portal if it's not working, but I'd rather it in Teams. It's much easier for me to grade. So please do me that favor. And then please make sure you're doing your attendance daily. If you have any questions, again, you can always post those in the questions for Martin. All right, now I'm going. Bye.